everybody, my name is Martin Sivak. I work for oVirt at Red Hat. I've been doing this for more than 2 years now. And today I'll be talking about something which is called hyper-converged. It's a concept, and we would like to tell you what the concept is about and how far we are with the implementation. And I'm sorry for being so high level, because after all the previous presentations, I'm not going to be talking about any C API or XML or kernel drivers. So I hope you will bear with me. Okay, so what I'll be talking about today might be pretty important for you, unless you know what oVirt is about, is the architecture of oVirt and what kind of storage we use. Possible failure points in the standard oVirt setup, which is one of the reasons we are doing the whole hyper-converged thing. And then some refresher talks about hosted engine, what it is, how it works in a very quick summary, and the same for Gluster, so you know about the technology we are going to use for hyper-converged. And then I'll show you how to put it all together and where we are, how to set up it, how to bootstrap it, how to manage it, and especially what's in and what's not. So let's get started. oVirt and its architecture. Can you raise your hand if you know what oVirt is about or if you've ever used it, please? Okay, that's more people than I thought there would be, but that's good. So for all the others, oVirt is a data center management system. You set up your physical hosts, you start some agents on those hosts, and then you have a nice management tool with a UI running in a web browser where you can start your VMs, migrate them between hosts, stuff like that. So what we do and how it works. It's a data center management, so we have the actual management platform that runs on top of JBoss, and traditionally it needed a separate host. So we had a single host that was doing nothing else than running a JBoss instance, and on top of that it was running our oVirt management suite. And that did you the web server, which you could use to do the whole management, to click everything, create storage, start VMs. Now, underneath that, you had your set of physical hosts. Those were the hosts that were used for running the virtual machines. And there was some communication between those two. So all the agents were communicating with the management. And then you have a separate set of hosts running your storage or some other storage solution. Traditionally, again, we used NFS or iSCSI, technologies like that. So you see that on the illustration here, that basically you had 3 different groups of hosts. You had the single host running management, you had a couple of hosts running your virtual machines, and then you had the storage solution. There are some running agents on the hosts. That's not really important for KVM folks, I guess. But this is how it works. Now, for the storage, our storage is basically the most important part of the whole management, because it is used for all the synchronization, it is used to store all the data, it's used for locking, so if we need to make sure that some VM is not running multiple times, causing a brain split or something, then we need the storage. We use SendLock. So everything is storage-based, everything is synchronized using the storage, and the storage is the most important part we have, plus the management platform which runs its own database. Now, you see on the illustration you can have multiple storage connections, and we support technology like NFS, FCP, iSCSI, and Gluster. Gluster is on a separate line because it's a different kind of storage. NFS, iSCSI, FCP, all are single-point services, basically. When you connect to NFS, you have to give it an actual NFS IP, unless you use some really magical technology Jason, I think Brooks has described in his Gluster setup blog post. Now, Gluster is a different thing. With Gluster, you set up multiple hosts that act as one, and you can connect to any one of those, and you'll get the whole thing. It's redundant. And I'll be talking about that in a second. So storage is very important. Now, what can happen and where the issues are if something goes down? So the network connection between your management machine and your host can go down, or the actual management machine can go down because of power failure, because of a bug in the kernel. I mean, there are many reasons a JBoss instance can go down. It should not, but it's a physical hardware, it's a single machine, it's a single point of failure. The other place which can fail is the connection to your storage. So if that happens, all your VMs will get paused because they need a storage connection. The engine will probably start throwing errors on you because VDSM instances, those are the agents running on our hosts, just lost connection to all the synchronization directories. So that's another place where something can happen. Your data are safe because your storage technology probably supports some redundancy. You can have RAID, you can have backups, but you just can't get to those, which is also bad. And especially Sunlock is relying on the storage connection. And if you lose your storage connection and it doesn't recover in a couple of minutes, I think, Sunlock can actually reboot your host, which is not really a good idea if you have important VMs running there. On the other hand, the VMs are frozen at that moment because they couldn't get to their storage, so it might be actually the best thing to do, just to restart them. Now, what we can do to remove those failure points. A single oVirt engine instance, that's the management, is needed, and we only have one. But what we can do, we can start the engine instance, the management, in a VM. It's a kind of a chicken and egg problem because you basically you are starting a management service inside a VM in a cluster that's supposed to be managing. So there is some bootstrap procedure for that. But it reduces the hardware failure risks. You can migrate the management across the cluster, and you can decommission hosts and still let it run somewhere else. So that's hosted engine. I'll give you a refresher about how it works probably on the next slide. And then regarding the storage, when you use Gluster, you basically get some of the safety features for free. So you have multiple hosts, you have redundancy, you can connect to any one of those hosts. You have some quorum features, so basically if you have 3 hosts and 2 are telling you that the bit is 1, 1 is telling you that the bit is 0, Gluster knows what to do and how to give you the right data. So as I said, when a storage issue happens, your data are usually safe, and because you are using some technology that supports data safety. But the infrastructure is not. So if you lose network connection, you can get to your storage. Gluster kinds of mitigates that. You can use a separate VLAN. You can use bonding just to remove, to lower the probability of the failure. You cannot get to 0, but you can get close. So that's Gluster. Now, hosted engine. I already said that hosted engine is the management running inside a VM. It's tricky to install. How many of you have actually tried to install hosted engine? Okay, except of our oVirt guys and our another oVirt guy. Yeah, nobody of you. Okay, so it's tricky. I mean, traditionally, we've introduced hosted engine like 2 years ago, something like that. And the installation was really tricky. You had to respond to multiple questions. Some of them required specific answers that were in correlation to a previous answer. And if you did it wrong, at the end, it didn't start, and you had to start from the beginning. So it was tricky, it wasn't easy, and it was very error-prone. And it's because it's a chicken and egg problem. So we were basically starting a host, then starting the management, then somehow injecting the host into the database so the management could see it, and preparing the storage for it, everything. We had a tool, and we have a tool for that, but it's still a pretty tricky operation. But when it when it's running, it's actually pretty nice. So you have a management that runs inside a VM, and you can do most of the stuff you can do to any other VM. You can migrate it across your nodes. You can mark it as highly available. We have daemon that makes sure that the management is actually running. So if the host goes down unexpectedly, the management is restarted on some other host. So you can get, I don't know, maybe I think it's up to 5 minutes downtime on the management, but it will start up and you'll be able to do stuff. The VMs are safe. I mean, if the management goes down, you will have no reporting and you can't do anything manually, but the actual VMs running are safe. So this is only about the management node. We have a special agent for monitoring that's running on all the hosts that are capable of running your management. You do not have to enable all the hosts to run the management, so you can only select the hosts that are more powerful or something like that. But again, hosted engine uses storage-based synchronization. So if you lose your storage connection, or if something happens to the data there, you are screwed and the management might go down, or it will probably be running, and when it goes down, it won't be restarted. So again, we are getting to the point that the storage is very important for us. Now, the hyper-converge is a concept I'll explain later, but there were some of the things we had to change to make this possible. So GlusterFS support was re-added to hosting engine setup. We had to remove it because people were trying to use it with low quorums, like quorum 2 in Gluster. If you know what that means, it means that you only have 2 hosts that have to agree on the result. And when you have only 2 hosts and one goes down, or if you try to connect two different hosts and you are writing data through 2 different hosts, it's actually hard to decide which copy is the right one because you only have 2 hosts. They have a different copy, different synchronization, so I mean there is a race condition. And since we rely on storage for synchronization purposes, it wasn't really good because both hosts wanted to tell us that, oh, something has higher priority, for example. So it was breaking the setup. People were complaining, and we told them what the issue is, but at the end, we just decided to remove Gluster support from the hosting engine setup. So people are not hitting that without explicitly hacking it. Now we re-added GlusterFS support to hosting engine setup. And we also worked with the GlusterFS team. So now we are using LibGF API. I'll explain what that means probably on the next slide or very soon. Before that, we were actually using NFS gateway for accessing Gluster. NFS has this inherent limitation where you need the single IP to connect to your NFS server. If the server goes down, you have to change the IPs everywhere. So that was another failure point we wanted to remove, and GF API allows us to do that. Now, I already explained to you how tricky the engine setup was. So we introduced an over-engine appliance. Simona was probably talking about that, I think, yesterday. So after me? Okay, so the next presentation will be about oVirt engine appliance. You will basically get an OVF image with pre-configured instance of the management, so you do not have to answer all the tricky questions, only about half of them. And it will spin up the VM with the management for you, which is really cool. You just install an RPM, start hosting engine setup. I'll show you how that works. I have some images or scripted demo, so I'll show you how that works. It simplifies the setup tremendously. Now, it also uses Cloud Init configuration. If you do not know what Cloud Init is, you might, but I don't know. Generally, it creates a virtual hard drive in the install system in the VM, and the operating system knows to check the hard drive and run some scripts from it. That's basically the summary. So basically, you start a VM, you somehow inject a USB key to it with the proper scripts, and when it boots up, it executes all the scripts and configures itself. And we prepare all that for you. So the appliance removes about half of the complexity from the hosted engine setup. Now, another improvement we did to hosted engine is that we are moving the configuration of the VM to shared storage. Again, the storage is important for us, but what we had till now, and what we still have actually at this moment, is that each host that's capable of running the management VM has its own config file which configures the VM. It specifies how much memory the VM has. It specifies how many CPUs the VM has. And we have a copy on each host. That's error-prone. If you want to change the configuration of the VM, you actually have to go to all your hosts and change the file. That's not nice, and it's not easy to do. So we are moving that to shared storage. We still have some backup plan, and we have a compatibility code. So if you don't have that, we will still pick up the configuration from the original file. It's also used for oVirt 3.5 to 3.6 upgrade, or when we introduce that. It's supposed to be there, but I'll tell you the situation in a second. So basically, we will use the old configuration, or if we have if it's there, we'll use the shared configuration. And what we do is we actually copy the shared configuration every hour or so. We copy it to each host, so we have an offline backup. If the network goes down, we can still spin up the management. So there are some compatibility reasons and backup reasons for us still having a local copy. But right now, the authoritative copy is going to be on a shared storage. That was actually a bit tricky. Simone did a great job in fixing that. And it allows us to do another thing, which wasn't possible before. We are introducing a management UI in the oVirt management platform, where you would be able to actually edit the VM, the hosted engine VM, directly from the management. It wasn't possible before. The VM was visible, but all editation was disabled because we had the specific configuration, and obviously you are not starting the management from inside the management. What you do is when the management goes down, the separate daemon is starting that. Chicken and egg problem again. So right now, what we'll do, we actually introduced, and we are introducing the UI. You will edit the VM, and every now and then, the config of that VM is actually posted to the shared storage, from where the whole daemon pair we use will read it and use it. So now, that was a really short hosted engine introduction. I'm sorry I can't be more specific, but the whole hosted engine presentation could take hours, actually. So let's move to Gluster FS. You might be more familiar with Gluster FS than with hosted engine. Gluster FS is a pretty nice file system. It's distributed. It has built-in fault tolerance, and it has a couple of layered architecture. And it doesn't require anything specific than a couple of packages, Gluster FS daemon, and a file system with extended attribute support. So if you look at the image, what you do when you create your Gluster FS volume is you create some partition. You do not even have to do that, but you have to force it if you want to use a directory. But you create a partition, you create a directory on top of that, and you tell Gluster, oh, this is my brick. Brick is it's just like a physical disk in the real world. It's just a place to store data. Then you take multiple bricks and merge them together to a volume. Volume is like your file system, basically. So you create a volume, and you can specify the properties of that volume. You can give it quorum information, for example. I'll show that on some other slide. So you can set up a stripe, a mirroring distribution Basically, the volume has some properties that control where the data are placed on the bricks. So you can have a copy on every brick, you can have copy on some of the bricks, you can stripe, so you can multiply the amount of free space you have. But that's the same as, I think it's rate 1 when you basically stripe. If any of those bricks goes down, you lose the whole file system. So you can select that, and that's how it works. It's complete in user space. Traditionally, there was a Fuse interface, so you used Fuse to access that. That used quite a lot of CPU. Now with the GF API, it's a bit easier. Let me go there. Yeah, this is what a brick looks like. You see, it's just another directory on your file system, and the only thing you do, you tell Gluster, this is a brick. This directory is my brick, and Gluster will start putting data there once you add it to the volume. So each brick inherits the limits of the file system, which is important. It obviously limits the amount of free space you get for this brick. The best practice says that all your bricks that are added to a single volume should be the same sized. Obviously, for mirroring, you need that. Otherwise, you are not using the full potential. So that's how it works. You are not limited in any way in the count of bricks you want to have on your system. So you can have multiple directories on a single host, and you can use those directories for bricks that are either part of different volumes or part of the same volume. Although having multiple bricks on the same host being part of the same volume doesn't make much sense, but you can do that. So now, this is about volume. As I already said, volume is the mountable entity. It consists of a couple of bricks, and you can select the mode it operates in. So you see that bricks from the same node can be part of different volumes. That's the usual way of doing that. You can have different types of volumes, distribute, stripe, replicate, and the most important property of a volume is the quorum settings, at least for us. The quorum setting specifies how many nodes have to agree on the actual data block. If you have two hosts, I already told you that you can have issues because when two hosts are start to argue about what a bit or byte value is, it probably uses blocks, but you get the point. There is nobody to decide who is correct. If you select quorum 3, which is the only mode we support, then you have 3 hosts. So when 2 start argue, there is the third host that can, check his own copy and give a vote to one of those 2. So basically, if you have 3 hosts, it's much easier to determine what is the correct value. And that's the only mode we support for these obvious reasons. We rely on the storage to be correct. If you have quorum 3, you can be pretty sure that what you get from Gluster is correct. If you have quorum 2, you get synchronization issues. So now I already talked about LibGF API support. So GlusterFS exports API for accessing Gluster volumes. This is the traditional way. So QEMU was connecting to the kernel virtual file system using the usual means. It was a mounted Gluster volume that went to the Fuse GlusterFS daemon that then talked over the network to its counterpart on the destination host, and that went to the Gluster brick and file system. As you can see, there are a lot of context switches. It goes from kernel to user space and back, so it's not that efficient. Fortunately, well, we asked the Gluster people, and they helped us, and they probably wanted this anyway. So they helped us, and we have a LibGF API support now. So Hosted Engine uses the direct approach. QEMU talks to the network directly, and it talks to the Gluster counterpart on the destination host without doing all the Fuse and kernel magic on the source host. That reduces contact switches tremendously. It improves the performance, and it's more direct. You can see that at least 3 different steps were removed, so that helps. Kudos to QEMU for supporting that. It's really cool. Now, I showed you all the bits and pieces, but those together are really just bits and pieces. And we are used to your bits and pieces to the low-level parts. But what we do, we actually integrate that to a product or to a project. So putting it all together requires a couple of ingredients. You need oVirt cluster. You need Gluster FS-backed storage domain. And you will get hosted engine that will maintain the high availability of the management. And you will install that using the pre-configured oVirt engine appliance to make it easier. Now, I have one disclaimer to make. Unfortunately, we found out a week ago that it wasn't totally ready to be pushed, to the public space. So we removed that feature from oVirt 3.6. So the freshest coming feature. The freshest coming version of oVirt won't have the nice UI and it won't have all the nice features. It's still possible to do a setup manually. It might be a bit tricky, it's still experimental, and we are working very hard on putting it back there, but right now it's not there. So I'm kind of ashamed of that, but we didn't make the feature freeze, so we had to remove that. So now I'll be talking about how the setup works, and while conducting you through the setup and showing you all the nice features we introduced or we are going to introduce, I'll show you the differences, and I'll show you what we have right now and what we don't. So the whole architecture of hyper-converged oVirt in Gluster FS, as you can see now, let me show you the first image. So this is the first image. We have a separate engine host, separate hosts for the VMs, and separate hosts for the storage. Now, if you compare it with this image, you see that we have a single set of hosts. The hosts are running everything together. Management is on those hosts inside the VM. Our VMs are on those hosts. The storage is on the same set of hosts. And that makes it easy to add a host, spin it up, and extend your storage, your CPU power to run the VMs. The boxes can be standardized. You don't have to care about whether you are adding a host for virtual machines or whether you are adding a host for storage. You get everything together. It also allows you to easily plan the migrations of your engine because all the hosts are equal, and that was our goal. The second goal we had was to allow running the whole oVirt environment on 3 hosts only. There are people requesting a really small scale setup, which would still be highly available. For Gluster reasons and for hosted engine reasons, we couldn't do this with 2 hosts only, because then we would only have quorum 2. And as I already said, the determinist, we can't determine who is right in quorum 2 setup. But with 3 hosts, we can do that. So this actually allows you to run 3 hosts in your office, very small scale office, and have storage, management, and the VMs with high availability of storage, of management, and of your VMs on that setup, which is one of the goals we had. So that's our plan. You can see everything is running on the same set of hosts. It allows you to do pretty nice things. So the actual ingredients. So we'll need at least 3 virtualization-capable hosts. Currently with CentOS 7.1 or RHEL 7.1 Plus, with oVirt repositories or Ravage on top of RHEL or on top of CentOS. Currently, we are actually not 100% sure about the status of Ravage. We'll have to work with the team to make it more seamless and more reliable. You will need at least 10 gigabytes of temporary space on the primary host. So when you have multiple hosts, you need to do the bootstrap, because you have no management running right now. You have nothing running, no VM. You only have your hosts. So you'll pick up one of those hosts, and you need at least 10 gigabytes of temporary space, which is usually not an issue on a physical host. But I did that in nested virtualization environment, and I was hit by that. So that's why I'm mentioning that. You'll need 2 separate partitions for data, at least 20 gigabyte 20 gigabytes of size. Again, one will be used for hosted engine, the actual VM that runs the management. We have a special storage domain for that. The second one will be used for all your VMs, so it will probably need to be a bit bigger than just 20 gigabytes. But this is the requirement. Then you can either use static network configuration, or if you use dynamic network configuration, you will need DHCP configure to map a MAC address to a fixed IP. That's one of the really tricky points in hosted engine setup. The VM gets an IP, and the host name has to match the host name you selected when you were doing the bootstrap. So you basically need a deterministic way of telling hosted engine that spin up this VM, give it this IP, and it has to have this host name. So you will need DHCP with the proper MAC address to IP mapping. You will need DNS with proper A and PTR records. PTR is probably not necessary, but it's the good thing to have. And then you will need to install the oVirt release package that prepares all the repositories on your hosts. Now, to install hosted engine, you either need a physical access to a console on one of your hosts, the primary one, or you can connect over network, but then we actually require, well, I think we don't require that, but we really recommend using screen to shield you from network connection issues. Like when we reconfigure the firewall and the connection is temporarily interrupted, it might kill your SSH connection, and that's not a good idea. So we recommend screen so you are shielded from this. Now, this is a step that will be done by the hosted engine setup after we finish it. But right now, we have to do it manually. So basically, creating your own Gluster volume is as easy as installing the proper packages. Yum install Gluster as a server, systemctl enable Gluster as a server. So you basically start the server, and that's just the daemon that manages everything. And then you create your directory for your Gluster brick. I used SRV Gluster hosted engine brick. It can be any path you want. Gluster tools kind of require that you use a separate partition for that. The tool actually checks for that, but you can force it to use a directory only. It's what I did for testing. I mean, using a separate partition is a good idea, so you are not starving your operating system, but it's not 100% necessary. It's probably recommended, though. Now, when you have the brick, and you basically create a brick on every host you have, so you can set up all the distribution in Gluster, you tell the Gluster on the primary node where the other nodes are. So Gluster peer probe, and you give it IP address of another host, and you execute it for each host you have. It internally prepares all the Gluster connections between those hosts, and the hosts will see each other. It also means that you can use any of those hosts to connect to any of those volumes you create. Independently on where the bricks are, you just use one of the IPs, it connects there, it gets the list of all the other hosts, and then it will use the bricks for data. And then the final step, you actually create the volume, and the bold part is really important. You have to tell Gluster that you want replica tree. So it actually starts using replica tree algorithms. And you give it the list of all the directories on your hosts. Then you actually start the volume, and it spins up the volume. You can't see anything yet in your operating system, but since this point, it's actually mountable. So there is another part of setting up the volume that will be done automatically again. But right now, this is specific for oVirt. I'm setting the quorum type to auto now because we are using quorum 3, but if one of the hosts or two of those hosts go down, we want Gluster to degrade, well, in a nice way. If you only have one host, you are also fine. You don't have any high availability, you don't have redundancy, but you can still read the data. And you can restart the VM, it will read the data probably, and then you can kind of fix your cluster. So you can start the other hosts back up. Then we have some timeout configuration. We have to allow access to the bricks from any host we have. We have to set some permission numbers, owner UID, GUID. Basically, that means that VDSM and I think it's the VDSM user and KVM group, so VDSM can access the actual volume. Allow insecure on, I'm not sure if it's necessary right now. It used to be necessary, but Gluster group did some work regarding to HTTPS and basically SSL connection. So is there anybody from the Gluster team actually here? Do you know how what the status of the SSL connection is? It's not necessary now. Next phase? Okay, next release. So Gluster will support secure connection in the next release. So now we have the Gluster setup that will be done automatically. And now this is what you will actually see when you start installing hosted engine. You install oVirt engine appliance. That's the nice thing we already introduced. That's one of the things we actually have right now. You install the oVirt hosted engine setup. And then Gluster FS server, some support packages. Now, when you start the setup, it starts asking you questions. One of the first question is, do you really want to install hosted engine? Obviously, that's yes. But then you need to specify the storage type. We added Gluster, so you select Gluster FS. You give it the full storage path to your Gluster volume. You can use any IP out of all those Gluster nodes. So I use the IP of my primary host here, but you can use any of those. It will automatically determine everything, and the high availability will be working. You give it a path to Gluster volume. It's not the path to any brick. It's really just / name of the volume, because Gluster exposes the volume names. And then hosted engine will detect whether you are running replica 3. We actually have the check now. So it will complain if you are not, and it won't let you go on. Then some other lines and questions will happen. Nothing really important for the hosted engine setup. And then it will ask you how the VM for the management should be started. When you select disk, it actually automatically gives you the option to use the appliance. It knows the proper locations for the appliance files, so it will automatically detect the oVirt appliance image. And it will give you the option to use it. So I did that. And then it allows you to customize the actual VM options, like the memory size. There is some default. I think I used the default here, 16 gigabytes of RAM. You can change it. It also asks you about the number of CPUs, if I'm not mistaken. And it asks you whether you want to use Cloud Init to actually customize the internals of the VM. Because memory size, that's still configuration of the actual VM, the virtual machine. It's not configuring anything with regards to the management, to the engine, to JBoss. But you actually have to customize the internals. So it will use Cloud Init. It will start a VM and run the scripts in the operating system. And here is one of the tricky parts. You have to give it an engine FQDN. So you actually have to give it a host name you want the management to use. In the past, this was the tricky part, because if your DHCP wasn't configured properly, if your IP wasn't configured properly, or if you used a different FQDN in this setup and in the oVirt engine setup running inside the VM, it couldn't talk to each other properly, and the install failed. Right now, you only give it one FQDN, and it automatically passes the same FQDN to inside the virtual machine. So we removed one of the points where you were eligible to make a mistake, and we did that many times. I mean, even me installing hosted engine using the original setup on the first try was almost impossible. You always did some mistake. So now the only thing you have to select is the MAC address, because I was using dynamic IP allocation. So you have to give it the proper MAC address to the VM, so it gets the proper IP that's allocated and matches the FQDN. So that's what I do. and then it just gives you all the information and asks you to confirm that. There were quite a lot of other questions you might want to select, but they are mostly about passwords. That's not really important for the installation, but obviously you have to select some root password for the VM. You have to select the password for the management. So those lines I omitted because they were not that important for the actual project I'm talking about. You can actually watch a full video of hosted engine installation with the appliance on YouTube. It's Simone did that. I just lost him. He just moved somewhere. But Simone did that, and as I said, he will have a presentation about how the appliance install works after me. So that's when you want the full details. Now, to finish setup of oVirt cluster, now you have a running management, but it doesn't contain anything. You can see one host there, the one that's running the management. You can see the VM with the management, and the storage for the management is hidden. So you only log in, you make sure that Gluster support is enabled, that you can add remaining nodes, you create and add the main storage domain. I have slides for that. So this is actually part of our UI. For all you low-level guys, this is something you do not see too often, I guess. It's not an API in C. But basically, you just check 2 checkboxes, and then all the hosts that are going to be added later will get Gluster support, all the Gluster support packages installed, everything enabled in systemd. All the firewall rules will know that there is Gluster connection support, so everything will be fine. It enables bricks and volume management from the oVirt engine API and the web admin. There's one caveat right now. We can shut down hosts from the management. I mean, if the host is not responding, we can reboot it. But currently, that code doesn't know that the same host is running Gluster storage, so it will happily reboot the host and kill your brick. We'll have to fix that, obviously, but that's one of the issues we have right now. Adding additional nodes. Yeah. Fencing doesn't have to be enabled, but that removes some other features. So it's one of the issues we have to solve. Adding additional host. Traditionally, you had to install hosted engine using the same setup. It omitted some of the questions because it detected that you already have hosted engine setup environment. But we basically simplified that to a single checkbox and one text box. So now additional host, you just click a checkbox, add a host, and it will run all the setup for you with all the right questions. Now, adding Gluster storage, we have a Gluster management in the web management UI. We've had it for some time, but it's constantly improving. So basically, when you want to add a new Gluster volume, you don't have to go to the node and execute the Gluster commands. That was only needed for the bootstrap. You select volumes, click add volume, and then you just give it the path to the bricks, and it will create a new volume for you. It even monitors the state of the bricks, so it tells you how many bricks are up, how many bricks are down. It gives you all the necessary information about the used space, about the quorum about the quorum status. So basically, you get everything nicely in the UI, and it just works right now. Now, you just add the new volume as the new storage domain, and you are ready to start your VMs. It will crunch some numbers for some time, like a couple of seconds, maybe minutes or 2. But then you will have everything ready, and you can start your VMs, you can create your VMs, you can start migrations. Now, things we are going to add, and we have the patches. They haven't been merged yet, so it's not totally ready, but we have it, is that you can edit the VM. So we actually want to support for editing memory and CPU allocation of the management VM, network configuration, and as I said, it's still work in progress. And I already described the mechanism. So the management creates an OVF file, which is the kind of standard description of a VM when you export a VM, and it puts that to the shared storage. And the hosted engine daemons that manage the high availability will pick it up And when the VM goes down, they will use that information to restart the VM. I only have 2 more slides, and one of them is thank you. So the other thing we are adding is a UI for hosted engine management, because hosted engine has a state machine inside, and you can configure that state machine. You can configure timeouts. You can configure some reporting, SMTP server, host scoring. So basically, the actual logic that controls where the VM is running. Yeah. So what's missing? I already said what's missing. We removed the automated hyper-converged setup because it wasn't ready. We need the full support for the VM management, and we need the hosted engine configuration UI. We have patches for most of that. We just haven't been able to merge that yet. Support for multiple Gluster brick servers is not ideal, and the Gluster people and actually QEMU people here might know about that already. Peter Krempa is actually the one who is assigned to that bug. When you are connecting to Gluster, QEMU only accepts one IP, not the list of all the possible IPs. So when the one host is down, it might not connect. But when it connects, the high availability works properly. So there is a bug where we need to be able to give it all the secondary servers so it can try other servers as well. And that's all I had. And if you have any questions about hosted engine, just ask me, ping us, send us an email. I am a couple of seconds, for like a minute or two overdue. So if you have any questions, just ask them now. OK, I guess I was too high level for you. So no questions. Thank you, and enjoy the rest of the event.